everyone, my name is Alia and today we're going to be discussing the process of generating the Lotus temple using Grasshopper. So a little bit of a background about the building. It's located in New Delhi, India. It's designed by Fariboz Sahba and its concept was basically to create a building that has a flower-like shape, like the lotus flower, and it consists of 27 marble petals that are grouped in 3 groups, each group containing 9 ribs. So the process we're gonna tackle to construct this building is to start with creating the form, starting with the exterior ribs and then going into the interior dome structure. And then we're gonna start designing the landscape surrounding the building with its road pavement and the vegetation and plant units. So we're gonna construct our mid ribs and outer ribs together because the outer ribs form the main entrance of the building, so we don't want to create the mid rib and make it snap to the ground. So therefore we have to create a relationship between them. So starting off, we're gonna create 3 different circles and divide them into a set of points while dispatching the mid circle through a true and false pattern, so we would be able to create this sort of line. Then we extract the midpoint of these lines through a perpendicular frame and move it outwards. So now we have our 3 points for the arc, and then we continue the rest of the arcs using the different relationships between the circles and their division points. And now we combine them together with an edge surface and mirror that surface through one of the arcs, and now you got our mid-ribs. And this strategy is basically how we're going to construct the whole building within its form and landscape, because it's basically about designing and creating that one module and then polar arraying it to the count of 9 around a circular rail. Now that we've got the mid-ribs, we're going to move on to the outer ribs that are constructed with a polyline, and then we're going to extract its midpoint through a perpendicular frame as well, and then moving it upwards through a series of multiplication and addition, and that was done to have a calculated move into a specific direction. And repeating the same process of the line, the extraction of the midpoint, and moving it so we can create the arc, and then creating the rest of the arcs and combining them together with the edge surface and mirroring them. And now we have our mid and outer ribs ready. The inner ribs is the exact same process of the mid ribs. The only difference is that we just tweak the radius of the base circle and the height of the top circle so that they fit to life measurement. So getting into the interior dome structure, we're going to continue on with the same policy. So we're going to use circles here, 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 and here, and divide the circles into a specific set of points and connect them together to create one arch, and then polar arraying it to the count of 9 along the circles. So starting off with a base and a mid circle, dividing them, and then iteming these 3 points from each circle, we are going to create our first arc that creates our base layer. Then we're going to go ahead and create another circle and divide it. Then we are going to use the previous divisions of the mid-circle, but instead we're going to call it, so now we only get the points that lie on the middle of the base arches. And now we're going to list item some of these points to create our second segment. And then after we polar array it, we get the desired overlapping of the original dome structure. The rest is a fairly simple process of also adding another circle, dividing it, and then using the division points between that circle and its previous circle to create this sort of line. And then going ahead and choosing only 3 lines at the top and dividing them, and then choosing these 3 points so that we would be able to create this arrowhead shape that would be later on polar array to create this sort of a star. Then I went ahead and swept the arches using a perpendicular frame, and then using the rectangle as my section and the arc as my rail, and basically just by plugging in a series battery and reversing the list and merging both of them together as the factor of the scale, we would be able to create this dramatic sweep of the arc going thin, then thick at the middle, and then going back thin again. So we would be able to create this sort of sweep. And after applying that all over the dome structure, we get this final result. Starting with the landscape architecture, we're going to start with a polygon that we are going to explode so we can find the midpoints of its segments and snap them to the origin. Then we are going to evaluate two evaluations. We're going to weave the first evaluation with the control points so we can create this polyline, which is the edges of the pawns, and then we're going to weave these two evaluations so we can create this polygon that we scale down, then use these two to create a loft in between them, then extract one unit and simplify it so it can act as a refined mesh. Then with these after exploding these, we can basically item specific lines and use their endpoints to create this line that we shatter into two segments, and using one segment to be offsetted on both sides, becoming a mesh that we move along this direction, and rotating it and simply lofting in between them. And while making the mesh UV for this part, make sure that the UV division is flowing seamlessly so that the simulation can run correctly, or you may run into some problems. Basically, after we create this unit, we mirror it so they are together, and we join them and clean them so they act as one mesh. And that is going to be our unit for the kangaroo simulation. We are going to take the naked vertices of that mesh and then using it to create the curve closest point and culling it into two sections using the smaller than a not battery. So we're going to divide the naked vertices into two sections. This section that we are going to anchor, and this section that we want to stretch to fit onto this curve to create the road pavement. And that arc was created by using the mesh corners and creating a polyline out of it and iteming this line and using its endpoints to create an arc. So now that we have our show edge length, so the mesh can stretch, anchor, and the on curve, we can easily run the simulation as you can see here. So it would be like that. And once we polar array it so it can do the road pavement for the whole building and smoothing the mesh, it is going to give us a result as such. So the construction of the pond is going to be fairly simple since we have the mesh and that polyline. We are going to create a line of the control points that snaps to the origin. Then we are going to evaluate the curve into 2 points, where one of them is going to be the center for a circle that we evaluate. Then we later on index, and then we choose the curve's closest points with the naked vertices of the mesh so that we make sure that the curve of the unit is going to fit perfectly with the curvature of the mesh. So we go on and interpolate it and then choose its endpoints and snap them to one of the points of the polygon. And after that, we divide the curve into a specific set of points and item some of them to create the second snapping that we use to edge, surface, and polar array to create the overall units. One of the fun things about this method of constructing the unit is that it depends on the mesh curvature for it to be correctly interpolated. And since the mesh itself depends on the simulation, that means that this unit also depends on the simulation. So for example, if we click reset, you can see that this is how the units act, and once you click true, it snaps back to place. And we can see that change with the road pavement. Altogether, we can reset, so you can see how it looks like. Then once you hit true, they fold back in place. Now we can get to the fun part where we explore the changing parameters of our design. So when it comes to the ribs, by simply changing the radius and height of the different circles we use to construct them, we can get introduced to so many interesting options. So for example, here we can have a more exaggerated curve. For the mid circle, if you change its radius, it actually does the opposite effect. So it becomes curved inwards and outwards by the outer segments of the rib. And also by changing the height, we can decide if you want to make the curve elevated or not, like that. So this is it, changing the height on its own. And for the top circle, it can help us open up the curves and arches, so we can either make them, especially if you look at the top view, we can make them close, and we can also make them open back up again, which is like a flower that resonates with the original concept of the building, which I find really exciting. And also you can change and play a bit with the height. You can either make it get down or go up. As for the outer rib that is created here, we can change the location of this arc segment, so it can go up or down like this. And when it goes down, it creates this nice effect. Then we can also change the location of the point that we calculated, so it can become much more sharper like that, or go back to its original place like this. We can also change the Z movement of the point that was right here, so we can make them extrude outwards or go back up inwards again. And the exact same type of change happens with the inner curve, with the manipulation of the height and radius and so on, that we already used to create it itself. As for the dome, we can change parametrically the amount of arches, because I used the same slider for all of them, which is 9. So now we can explore the different options that can be created, whether they start to overlap even more or they decrease and they become much more smoother. And that also helps us create some interesting options that maybe if we try the sweep, it would create an interesting pattern. So let's see. Yeah, so this is one of the possibilities. As for the mesh that we constructed, since we have a point here, we can change the angle of it so it becomes extruded instead of being flat, as you can see here. And you can also change that midpoint, so you can either make it stretch farther or relax more. So it can become this, which is an actual flower that I find cute, and it can also go back in again and stretch even more. while having the kangaroo solver running. As for the units that we've created, we can use the advantage of the evaluate surface, since the point that completed the edge surface is an evaluate on the line, so that means that we can move the edge surface to hit the starting point of the line or bring it all the way back in to create this interesting pattern, as you can see here, moving outwards, then inwards. Then I tried to play a little bit with the V-Ray renderer and created 3 different renders. The only difference between all of them was the camera and some position. So this is the final product of the overall design and the V-Ray rendering. This is another picture I took of a cool moment that showcases the ribs with the dome and the overall shadow. And this is a solo picture of the shadow that the dome casts on the ground floor of the building. And with that, we conclude our process for designing the Lotus Temple using Grasshopper. Thank you so much for watching if you made it this far, and hope to see you soon.